Today we're going to go over the Trigonometry Unit Review Day 2. All right, number 1, f of x equals negative 6 sine of 5x plus 1. Type the period of the function, write your answer in terms of pi. All right, well, period is equal to 2 pi over a value called b, and that b value is this value here. This is our b, right? And that's also known as frequency. So when you're trying to model functions, we call this the frequency of the periodic function. We would go ahead and do 2 pi over 5. And since you can't reduce 2 over 5 anymore, you would have just written 2 pi over 5. So the way we would have written this would be 2 pi slash 5. Number 2, we're going to go ahead and do the same thing. This is our b value, right? So to find the period, it's 2 pi over that b value, which is 8. Now, you do have to simplify fractions, so you should know that 2 over 8 is not simplified. So we rewrite this as 2 pi over 8, just to rewrite it. And if you divide the top expression by 2 and the bottom expression by 2, you would get pi over 4. And just as a quick reminder, if you hang out on Desmos and you try to have Desmos simplify an expression like this, it can't. Let me show you. So 2 pi over 8, according to Desmos, is 0.785, etc. Now, to get it in simplified fraction form, you have to remember that Desmos can't find rational expressions with pi fractions. So we just get rid of the pi, and then you'll get the decimal, 0.25, but you have this icon over to the left that looks like a fraction. So if you click it, you get the fraction, 1/4. So 2 over 8 is 1/4, and then we just replace pi back in the numerator. So 1 pi over 4 or pi over 4, as we have here, pi over 4. So pi slash 4. Oh, and again, you can't write the pi symbol, so we just type pi. Pi over 4. So this one's a little more interesting. So I'm just going to kind of cut to the chase here. This would be 2 pi over 3/4. Which, if you recall, multiplying by fractions, this is actually, dividing by fractions, this is 2 pi times the reciprocal of 3/4, which would be 4/3. So this would be 8 pi over 3. And 8 over 3 doesn't reduce, so 8 pi over 3 would be the answer, 8 pi over 3. Number 4, our b value is pi in this case. Any coefficient you have multiplying x, that is still your b value. So yes, that is still the b value, the frequency. So this would be 2 pi over pi, which pi divided by pi does cancel, just like any other factors that are the same. So the period is actually just 2. So the period is 2. Next question, 2 pi divided by my b value. My b value is 4 pi this time. So just like before, pi divided by pi does cancel as a factor, but you still have to reduce 2 over 4, which is 1/2. So you could have written this, I believe, as 1 over 2. So 1/2 would be the period in that case. All right, number 6, they want us to give the period of the function p of x. So to find period, what you have to notice is if you're dealing with the full cycle of the periodic function. So if you remember with sine, the standard cycle sounds like this. Let me go ahead and write it. So for sine, we're used to this pattern. It starts at the midline, it goes to the max, comes back to the mid, then to the min, and then back to the mid. And then cosine has the same values, but they're switched up. Cosine starts at the max, comes to the mid, then down to the min, back to the mid, and then back to the max. So let's see what we have in p of x here. So p of x starts at -4, goes to 1, back to -4, down to -9, back to -4, and 1. So hopefully you recognize how these values relate to each other. So -4, as you can see here, is repeated quite often. So this is probably the mid. And obviously I'll address and prove that I know it is the mid, because in between the first two mids, we have 1, which is above -4. So that would be my max of the periodic function. And then it drops down to -9 between these two mids. So that would be my min. So we have a mid, max, mid, min, mid function, which means this must be sine. We'll come back to that later. We don't need that right away. But the period of this function would be where it starts, or the distance in which it starts and ends that cycle. So that'd be from here to here. So the length of x is from 0 to 2 pi, so the period is 2 pi. Right, so you have to look at the x values to know the fact that it starts at 0 and ends at 2 pi. That is a distance of 2 pi, right? 0 to 2 pi is 2 pi. So give the amplitude of the function p of x. So the amplitude, just kind of looking at example of a graph, just to remind you graphically what this means. I could do a little better than that. Something like that. Now, if you have a midline, like this, amplitude is the distance from your midline to the max or the midline to the min. Okay, so if you look back at what we did in the first part, even though it didn't ask it yet, I kind of discussed where the midline values are and the max and the min. So here's our max of the function, because it's the largest value in the table, and here's our min, and then this is our mid. So just decide what is the distance from -4 to -9, or -4 to 1, right? And if you ever want to find a distance, you could just subtract. So we can go ahead and do what is the mid minus your min, or you could do the max minus your mid, right? We're just trying to find the distance between these two values. This one would be -4 minus -9. And the max minus mid would be 1 minus a -4. And if you have to ask a calculator for help in both of these situations, just know that both answers turn out to be 5. So that'd be the amplitude. The distance between the midline and the max, or the midline and the minimum, is a distance of 5. And it's a positive distance, so amplitude should be a positive value. Okay, give the equation of the midline. Well, we already talked about how the -4 values that it keeps coming back to must be our midline values, right? So that would be the equation. Y equals -4 would be our midline equation. All right, so now we're expected to put this all together. Recall that A is the amplitude value. B is what we call the frequency of the function. And C is the midline value. So you have to look back at the previous problems if you don't recall. The midline we found was the -4 value that showed up on our table quite a bit, so -4. The amplitude of this function was 5, so amplitude is 5, or 8, yeah, so our A value is 5. And then B, the frequency. Now the only problem with frequency is it doesn't appear in the equation, this B value. So to find B, it's similar to the period equation, but now you're dividing by the period. So to find your B value, you just take 2 pi divided by your period, and 2 pi divided by our period of the function, we found that the period was 2 pi. Anything divided by itself is 1, so that's my B value. So if I were to write out this equation, just to make sure it's very clear, what we're actually finding is this. If you were to hop on Desmos and type in this equation, 5 sine of 1x minus 4, this function graphed would give the same values as the table that I gave you on the assignment. So if you want to confirm your functions anytime you come up with these A, B, and C values, you can feel free to graph them and show that you got the same values as the table. Okay, for the next one, you have a cosine function table. And it says give the value of d of pi over 4. So remember, in general, when you have function notation, like if I said f of x equals y, what you want to recall is that this f value, it's not really a variable, it's just known as the function name, right? So this is the name of the function. So this function's name would be f, and similarly, our function's name is d. Has nothing really to do with the algebra of the problem. We're not using it to do anything. It's just a naming convention so that when we look at the table, we know we're talking about the same function. Now, what's most important is that x is known as our input value, right? Like, what are we plugging into the function? And then y represents what we get back from the function. So y is known as our output. And I named these very specifically the input is known as the x value on a table, and the output is known as the y value on a table. So the reason why I'm going over all this is to make sure that when you see give the value of d of pi over 4, it's talking about an x value, which is up here, x equals pi over 4, and this would be the y value, the return value, 10. So the answer is just 10. Similarly, we're asked to find d of pi, so we go on the x to find where does this table talk about x equals 10, and it's right here. Sorry, where does the table talk about x equals pi? And the return value, the function value, is 3. So d of pi equals 3, according to the table. All right, this next question is just asking to find a little bit of a pattern here. So we have 3, 10, 17, 10, 3, and then there's this value n, and it says if d of 5 pi over 4 equals n, meaning this value here, if x equals this, what is this n value, right? Like, what does this equal? Well, if we remember how cosine works, cosine likes to start at the maximum. Now, in this case, though, if you look at 3 is the smallest value in this table. So this pattern actually is the vertical reflection of cosine. So this would be like a negative cosine function. So this starts at the minimum, then it comes to the mid, then it goes to the max, back to the mid, and then to the min. Now, that would complete one period. So to know what's going on with this n value, we just have to complete the pattern, or repeat the pattern, I should say. So it goes min, mid, max, min, max, mid, min. And then when you start the pattern over, whatever came after this min, see how after min it went to mid? Then this would also go to mid, right? After one complete period, it just repeats the cycle. So our mid value is 10, so that would be the answer, 10. So give the period of the function d. Well, we just kind of went over the whole how it goes. I'll just rewrite it. So once a periodic function sine or cosine goes to the first main 5 values, that would be our cycle there, right? That's one period of the function, and that took x equals pi distance to do that, so that's the period, pi. And I guess we would probably say pi if you have to type it. Give the amplitude. Well, this one's a little easier just because the values are all positive. So just find the distance between these values, right? So to get from 3 to 10, you have to add 7. And to get from 10 to 17, you have to add 7. So the distance between any of the mid to max or mid to min values is just a distance of 7. It's called our amplitude. Okay, so let's put it all together again. So our midline value, we talked about how these are the midline values, right? So these are the mids, because it's like vertically in the middle between 17 and 3, right? So that would be the equation of the midline. So the midline equation is y equals 10, which would be our c value that goes here, so 10. We previously talked about how the amplitude is the distance between your mid and your max and mid and your min. So it would be 7, but there's a catch. A is 7 if you're only talking about the amplitude, but A actually can hold a little bit more information. So I'm going to illustrate this using Desmos. So if you hop on Desmos and you type in cosine x, I'll zoom in here, you'll see that cosine starts at the max, comes down to the min, then back to the max. So it starts at the top, goes to the bottom, back to the top. But if I also graph alongside this negative cosine x, what you'll notice in this green graph is a negative cosine x flips this vertical pattern. It starts at the minimum, comes up to the maximum, then back to the minimum. So the reason I'm showing you this is if you look at our table does start at the minimum, and then it does return to the minimum, and in between them you have the maximum. So that actually means our A value is not just 7, it's actually -7. And then to find B, you take the period, and you have the expression 2 pi over your period is your B value, and we have 2 pi over pi, right? This value here is where our period, or the period ends of the function. So this would be 2. So that's our B value, 2. So our function is -7 cosine of 2x plus 10. We have a graph of a function called f and a table of a function called g. And number 16 is asking us a true-false question. F of x has a greater period than g of x. All right, well, let's go ahead and see here. My graph of f of x starts us here and ends a period here. So that would mean my period is right here, right? That's the length of my period, 8 pi, right? And then my table begins its period, or begins a cycle here at 0, and it ends here at 4 pi, so that would be the period of this function, 4 pi. Function f of x has a period of 8 pi, and function g of x has a period of 4 pi. So f of x has a greater period than g of x, that's true. Next question, same graph, same table. F of x has a greater amplitude than g of x. Okay, so remember, amplitude just means the distance from a midline to a max or minimum value. Well, I'll just go easy here. If I start here on the midline and I count how many units up, my y-axis does count by ones, so this is a amplitude of 3. But if you look at my table, it goes all the way from 8 to -1, so that's -9, and then -9 to -10, so that's -9. So the distance is 9. It doesn't matter if it's negative or positive, it just means the distance between the midline to those values is 9. So g of x has an amplitude of 9, f of x has an amplitude of 3, f of x has a greater amplitude than g of x, that is false. And again, that's because 3 is less than 9. Okay, f of x has the same midline of g of x. Well, on the graph, it's really easy to see your midline. It's dotted here for you, so that's where the midline value starts. So our midline is y equals 1. Well, if you look at my table, this happens to be a cosine graph, and the way I know that is, well, 8 is the maximum of this table, and it returns to the maximum here. So that must mean that right in the middle we have our minimum, and in between our max and mins we have our midlines. Sorry, our midline values. So our midline is at -1 of this function, so this function's midline value would be y equals -1 is our midline. So they don't have the same midline. One of them is 1 and the other one is -1. So nope, false. All right, select a true statement from below. All right, so they want us to compare what's happening at 4 pi and 2 pi for the most part. So let's see what's going on at 4 pi. So f of 4 pi is right here. So that's 4 pi comma 1 on f of x. And for g of x, 4 pi is right here. So that point would be 4 pi comma 8. So this says that the output value at f should be greater than the output value of g. And that's not true because we have 1 is greater than 8. That's false. Okay, the next one. It says what's going on at 2 pi. So at 2 pi here, this would be 2 pi comma -2. -2. And they're checking if it's less than what's going on at 2 pi here. So this would be here. This point would be 2 pi comma -10. So is -2 less than -10? It's greater, so that's also false. Okay, let's check the next statement. Well, the next statement is just reversed. So that would be the same values, right? This would be -2. But now we're asking if that's greater than -10. Well, if -2 is less than -10 is false, then if you flip the inequality, it's true. So that's our answer. This for sure is true. Okay, 20. Select the false statement from below. Let's look at what's happening at 0. So g of 0, so at 0, right here, this would be 0, 8. So 8 is greater than whatever's happening with function f at 0. So function f at 0 is right here. That's 0, 1. So 8 is greater than 1. That's true. But remember, careful, we're trying to find out what's false. So be careful. Make sure you read the condition of the answer. All right, the next one. G of 5 pi is less than f of 5 pi. Well, f of 5 pi, zoom out a little bit here. F of 5 pi would be right here. So at 5 pi, this function is at 3. But g of 5 pi, it wasn't completed for us, but if you recognize you have a periodic function, you should be able to recreate the value quite nicely. So my function goes 8, -1, -10, -1, 8. So after 8, it just repeats the previous 8. So this should be -1. So this would be 5 pi -1. So to recreate the statement, this would be -1 is less than 3, which is true. But again, we're looking for what's false, so be careful. All right, next statement. F of 4 pi is less than g of 4 pi. Well, f of 4 pi is here. So that point is 4 pi 1. And in my function g, that's right here. So 4 pi comma 8. So this would be written 1 is less than 8, but that is true. And very similar to the last problem, if you look at this fourth choice here, f of 4 pi is greater than g of 4 pi. Well, if the less than condition was true, this would just flip the inequality. This is saying 1 is greater than 8, which is false. And that's the condition I was looking for. Which one's false? So that's actually the choice. This is the only false statement. And lastly, we just have to select the correct equations for functions f and g below. Okay, well, first things first, let's talk about f of x. F of x has a midline of y equals 1. And if you remember, g of x had a midline of y equals -1. And that's because of these values here. These are the midline values. Okay, so what I can do right away is I can look at my choices, and any function that doesn't have a midline of 1 or -1 cannot be the functions. So let's see here. Unfortunately, they all have positive or -1 midlines, so can't really toss out any choices yet. Okay, next thing I can talk about, let's go after f of x. So f of x has a midline of 1. It has a amplitude of 3, right? Amplitude of 3. It does start on the mid, right? It starts right on the midline. So that means this has to be a sine graph, but it also doesn't go up to the maximum first. So this has to be a negative sine graph. So this models, or this kind of has the same behavior as a negative sine function. So let's put this all together. I need a negative sine function that has an amplitude of 3 and the midline is 1. Now, I can't incorporate the period, but let's see if there's any options that could be possible here. So it looks like the only two contenders would be these ones. Now, the last thing I can do to make sure I have the right answer is we can talk about this b value. And b value is 2 pi over the period. And if you go back up to the graph, the period of this function was right here, right? That's my period of the graph. So that's 8 pi. So going back to my calculation, 2 pi over 8 pi reduces, pi's cancel, 2 over 8 is 1/4. So my b value is 1/4, so it has to be this choice. So we found f of x for sure. Now let's go after g of x. So if you recall, we know that the amplitude was 9 from a previous problem. So this one does start at the max, back to the mid, and then down to the min, and then back to the max after this mid. The amplitude was 9, so amplitude is 9, because there's a distance of 9 between those values. And since it does start at the max, this would be a positive cosine graph. And the midline has to be -1. So which possibilities do we have? This could be, I'll switch colors here. This could be g of x, because it has the correct amplitude. It's positive cosine graph, and the midline's -1. And it could be this function. Last thing is we can find the b value like we did before. 2 pi over the period. And this table shows us that the period is right here when you complete the cycle, right? Max to max for cosine. So this would be 2 pi over 4 pi, which if you reduce, the pi's cancel, and 2 out of 4 is called a half, and therefore this must be the function. All right, I hope that helped with Trigonometry Unit Review Day 2.